All right, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
All right, so we're going to be looking at past paper. This is a 2017 paper, but it is a January setting. All right, we have 40 minutes free. So if the time runs out, I'm going to ask you to just log back in because we have 60 questions on the paper, and maybe it will take more than the 40 minutes to cover. All right. Now, before we start, I'm just going to give you a tip or two on your multiple choice paper. First tip is that you should not leave any. All right, sorry about that. All right, so do not leave any questions unanswered in the exam. Second tip is that usually two of your options are close and two are going to be far off. So if you can manage to eliminate the two that are far off, then you are more likely to get the answer correctly from the two that remain. All right, so first question, how many significant figures are in the quantity? 25.92 cubic meters. Now, what I'm going to do, or what I will be doing, is to give you a bit of theory for each question. It's not long, just a short fact, and this will help to guide you to answer the questions. All right, so you need to remember that all non-zero digits in a number are significant. And in this number, our measurement, we have 4 non-zero digits. And therefore, all 4 digits are significant. The answer would be D. Second question, also a measurement question. And you have to read the volume of liquid. So please remember that you read the bottom of the meniscus. So if your eye is level with the bottom of the meniscus in this case, it should read 7.5 cubic centimeters. And therefore, your answer will be B. Number 3, this is an optics question. In carrying out an experiment to locate a real image using a converging lens, the object can be placed, and you are given three options. So which one or two are, if all of them apply. All right, so for converging lenses, you have to remember that real images are only formed when the object is placed at these four positions. So if the object is between F, that is the focal point, and twice the focal point, or the focal length, then a real image will be formed. Also, if the object is at 2F, beyond 2F, and at infinity, which is just a very, very far distance. All right. So these four places are where the object has to be placed for a real image to be formed. And so only 3 applies here. And therefore your answer will be C. Number 4, which of the following instruments is suitable for measuring the diameter of a hair? Now, the diameter of a hair is very small. It falls in the micrometer range, and therefore the answer should be a bit obvious. So that we use a micrometer screw gauge. The answer is D. All right. Number 5, you have 3 immiscible liquids, P, Q, and R, and their densities are all different. Now, if Q is denser than P, but less dense than R, each of the following diagrams show how the liquid settles in the measuring cylinder. So, denser liquids will fall at the bottom, while the less dense ones will float, and therefore, if Q is denser than P, then Q should be below P, all right? But you're told that it is less dense than R, all right? So that R should be at the bottom and P in the middle and Q at the top. The answer. All right, sorry about that. Q is denser than P, but less dense than R, right? So Q should be in the middle. All right, someone is asking about the recording. Yeah, the recording will be available. So possibly on YouTube or so. All right, so next question. The mass of an astronaut is 70 kilograms when standing on the moon. When he returns to Earth, his approximate weight will be what? Now, even though, well, you are given mass, all right, but the mass doesn't change. So even though he's 70 kilograms on the moon, he'll still be 70 kilograms on the Earth. But what you have to find is the weight, right? So we know that weight is the product of mass and the gravitational field strength, which is approximately 10 newtons per kilogram. So if we multiply his mass, which is 70 kilograms, times 10, we should get 700 newtons. So the answer is D. All right, number 7. When a force is applied to a spring of original length L, the new length becomes L plus X. what would be the new length of the spring if a force of F divided by 2 was applied. So that's half of the original force that was applied before. Now, based on Hooke's law, we know that the extension is directly proportional to the force, not the length. All right. So the length is not directly proportional to the force, but the extension is directly proportional to the force. So if you have half the force, then you should have half the extension. So it's x divided by 2 plus the original length. That would give you the new length. All right, the answer should be D. Next, we have a vector question. So we are given 3 force vectors, L, M, and N. They're all in the same plane, meaning that they can be projected on a flat surface. And we are told that the ring is stationary, meaning that it all right, so the ring is stationary, not moving, and therefore there's a perfect balance between all of these forces. All right, so since L and M are at right angles to each other, right, it means that N, which would form the resultant, right, N should be equal to the resultant of L and M. So therefore, if we use Pythagoras theorem, right? So if we complete a parallelogram, it should be a rectangle, and then we draw the diagonal, we would see that n squared is equal to L squared All right, so n squared is equal to L squared plus m squared. And so the answer should be A. All right, number 9. Linear momentum. This requires you to know the definition of linear momentum. So linear momentum is the product of a body's mass and velocity, and therefore your answer should be B. Number 10, which of the following features must be present in a stable, well-designed racing car? And our theory says that the stability of a body is greater when it has a low center of gravity and a wide base area. So obviously, you would rule out narrow wheelbase. Sunroof is not important in stability, and neither is a long front. So your answer should be A. All right, number 11. So this is talking about energy conservation, energy efficiency. And normally, once you're using solar, it will be more economical than to use electrical energy, right? So one, washing fewer and larger loads in the washing machine. Yes, this will conserve energy, right? Because you're using the machine fewer times, even though the loads are larger. But the fewer time you use the machine, the less energy will be expended. Using a solar water heater, of course, this works out much cheaper than an electrical heater. And hanging clothes out to dry, of course, you're not really using any electrical energy. You're just depending on the sun's energy. Therefore, all three applies. Answer should be D. All right. When a ball is thrown vertically upwards and reaches its maximum height, it has, so this one is about energy, kinetic and potential. And we know that when the ball reaches the maximum height, it becomes stationary for a short period of time. And when an object is stationary, it has zero kinetic energy. So your answer should involve minimum kinetic energy. So which of these says minimum kinetic energy? You have this, E, minimum kinetic energy, and the ball is at its maximum height, so it has maximum potential energy. The answer should be C. "13. A large heavy parcel is tied with string. It is less painful All right, why is it less painful for a person to pick up the parcel if a cloth is wrapped around the string? Now, is the force on his fingers less? The same parcel, so the force will not be less. But we know that the pressure is what will cause the effect of the parcel to feel painful. The string exerts a large pressure, but if the cloth is wrapped around the string, then the area that the finger is exposed to becomes greater, and so if the area is greater, then the pressure will be less. All right. So your answer should be reduces the pressure on the fingers. So that's B. Number 14, the specific latent heat of vaporization of water is 2.26 times 10 to the 6 joule per kilogram. When 0.01 kilogram of water is converted into steam, how much energy is given out or absorbed? Now, for a liquid to change into a gas, heat has to be absorbed by the liquid. So your answer has to involve some absorb, not give out. So eliminate the two that says gives out, and you focus on the two that says absorbs. Now what this is saying, 2.26 times 10 to the 6th power joule per kilogram. It's saying every kilogram of water that is converted into steam requires 2.26 times 10 to the 6 joules of energy. So therefore, if you have 0.01 kilogram, which is 100, your answer should be 100 of this value. So that would be 2.26 times 10 to the 4th power. So it's B. Sorry, A. Right, so A. We'll eliminate the gives out. So A, 2.26 times 10 to the 4th. And number 14. All right, so what I'm saying is that, just listen carefully, 2.26 times 10 to the 6 joules, right? That's 2,260,000 joules of energy is required to change 1 kilogram, because this is per kilogram. Kilogram to the -1 is for each kilogram, it requires this amount of energy, 2.26 times 10 to the 6th power. But now you want to change only 0.01 kilograms of water into steam. What fraction of 1 kilogram is 0.01? All right, so that's 1 divided by 100. And therefore, the amount of energy that is required for this amount of water should be this value divided by 100. So if you divide this by 100, you get 2.26 times 10 to the fourth. All right, because 100 is 10 squared. 10 to the 6 divided by 10 squared should give you 10 to the fourth. All right, number 15. So you have a copper rod being heated in the middle, basically. The middle is Y, and then at the extreme, all right, so there are some issues that I'm not sure what is happening, where I am being kicked off every minute or so. All right, number 15. All right, so we have X and Z at the extreme, and therefore the heat is being applied directly at Y. All right. Now we know that heat travels from warmer areas to cooler areas, and therefore it will travel from Y to Z and also Y to X. All right, so Y to X and Y to Z. You should have A for your answer. Number 16. All right, heat capacity. Now, the heat capacity is the energy required to raise the temperature of a substance by 1 degree Celsius. So if you look at your answers, options, you'll see so D matches our definition over here. All right, so the answer should be D. Number 17, this applies to the general gas equation, where all three changes, all three variables, pressure, volume, and temperature changes. And for the gas laws, we know that the mass of the gas must be constant. The temperature must be in Kelvin, so that's correct. P1 and P2 must be measured in millimeters of mercury. This doesn't have to be so. The pressure and volume measurements can be in any unit. So 3 is out. 4, the units of P1 and V1. All right, so 1, 2, and 4 are correct. The answer should be C. Number 18, which scientist was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy? Now, it was Joule who established that energy different forms of energy are equivalent based on his experiments because they involve actual measuring of the amount of energy. All right, Rumford did not do any measurements with his experiments, and so Joule is the person, and so it's really A. All right, number 19, which of the following methods is the most suitable for heating a brass bulb in order to determine. All right, now if you are trying to get a substance to be in thermal equilibrium, then it has to be placed in an environment where the temperature remains constant for a good amount of time. If A is done, you have no way of knowing the temperature of the bulb, because this will elevate the temperature to a very high value, and you would be able to measure that on a regular thermometer. Neither will B, right? And so if we place it in a boiling water bath for 10 minutes, then it will. All right, so your answer should be C. Number 20, student carries out an experiment to determine the specific heat capacity of a solid using the electrical method. Which of the following equations should be used? So in the electrical method, you have to find the energy by using the power equation, right? Electrical power is equal to V times I, and if we multiply V times I by T, we are going to get the energy. So I times V times T gives us the energy, because I times V is the power, and power times time gives us the energy. Now, when we substitute this in the equation for finding the specific heat capacity, we will see that IVT is equal to MC delta theta. So then we substitute for C and we make C the subject of the formula, and therefore C is equal to IVT divided by M delta theta. All right. C is the specific heat capacity. IVT is the energy, and M delta theta mass times the temperature change. So the equation that matches here is IVT here, C, IVT divided by M delta theta. So your answer should be C. 21, the energy required to change the state of a substance was determined to be EH. If the mass of the substance was doubled, the value of EH will. Let's look at what this says. The latent heat is a constant for that substance. So EH and M are directly proportional. So as the mass increases, so does the amount of energy that it requires to cause the state to change. So if the mass is doubled, then the energy should also double. And therefore, your answer will be B. (22) The specific latent heat of vaporization of water is energy required to change 1 kilogram of water at. No, so latent heat of vaporization requires that the temperature remains constant. This is a state change, so the temperature has to remain constant. And water at the boiling point is 100 degrees Celsius, and you're changing that to steam at 100 degrees Celsius. So the temperature remains constant here. And so your answer should be C. (23) All right, so infrared radiation, it's long wave. All objects emit infrared radiation. And the infrared radiation has low penetrating power due to its long wavelength. So the long wavelength infrared will not be able to penetrate the glass, and therefore they stay inside the greenhouse and increase the temperature. So we have D matching that. (24) The specific latent heat of fusion of water is 340 kilojoules per kilogram. This means that every kilogram of water requires 340 kilojoules to be taken away from it for it to freeze. This time is taken away because we're going from water to ice, right? So the heat has to be taken away this time. Every kilogram of water requires